So we talked about it, at least for a recursive formula, what the definition of a recursive formula is. So let's do that one first. Number 2, a recursive formula, how would you define that? Okay, let me get you started here. A recursive formula gives a sub n, right? A sub n. I'll have to write that in here. It's faster than going to math notation. It gives a sub n in terms of what? So a sub n stands for the nth term of the sequence, right? So it gives a sub n in terms of one or more of the previous numbers in the sequence, right? So that's like the Fibonacci sequence. So a recursive formula gives a sub n the nth term in terms of previous numbers. I'll put, even though grammatically one way you read it wouldn't be right, I'll put the numbers in the s in parentheses because it may be one number, right? So a recursive formula gives a sub n in terms of previous numbers or outputs in the sequence. And as an example, I'll say see the Fibonacci sequence. That was our first example, and it happened to be the recursive formula is what we happen to come up with there. Now, an explicit formula is what we just dealt with in the last problem where we found the first 4 terms. An explicit formula, this is going to be very, this word I'm going to use is going to be very technical, this phrase, I guess. An explicit formula is a plug and chug formula. Plug and chug. For I'll just write it out, nth term of the sequence. So you know, if you want the 1,000th term, you plug in 1,000, do the arithmetic, out pops 1,000. And you can see that with the previous example. So, and again, I used nth term. This is the same as saying like a sub n, or it doesn't have to be a sub n, it could be x sub n or something like that. So the example of that was the last example. I'll say C, last example. So that's where we found the first 4 terms. This guy right here is a plug and chug formula. If you want the 1,000th term, what is it? A sub 1,000. What would it be? 500. It's that quick. So that's the advantage of an explicit formula. Sometimes explicit formulas are hard to find. That's the disadvantage. And the Fibonacci sequence is a prime example of where the explicit formula is hard to find. Okay, I want to give you guys some practice since I'm going to be talking at you a lot today. I want you guys, this is an explicit formula, so I want you guys to practice finding the first 3 terms. So A1, A2, A3. Not group work here, this is just quick practice. It won't take very long. Now, you can, of course, talk to each other, though. So find A1, A2, A3, just in your note. And if you're having any trouble, just plug the subscript, the relevant subscript in for n. Do the arithmetic. Okay, what did you get for A1? Anybody? -6 is what I got. What did you get for A2? 9. A3? -14. Any issues? And don't be afraid to ask questions in this class. That's how you learn. And you also learn by making mistakes. You learn more from your mistakes than anything else. So any questions on how we got that? Why did the negative disappear in A2? Because you're plugging in 2, right? Everywhere you see an n, you're plugging in 2. -1 to the second power is +1, right? Yeah. So, and then you plug in the 2 here, you get 2 squared plus 5 is 9. So it's a +9.